Assalamualaikum warahmatullahi wabarakatuh. Welcome to my channel. Hello friends, how are you? I hope health and goodness are always with you and your family. And I hope the case of COVID-19 ends soon and we all live in normal condition again. In this pandemic, please take care of your health with practice social distancing, wear a mask, wash your hands, and use hand sanitizer frequently, and follow the protocol of handling COVID-19 in your country. Okay? In this occasion, I will discuss a little knowledge about HPLC. What is the HPLC? High Performance Liquid Chromatography, or high pressure liquid chromatography. Okay, for people who are studying or working in the field of natural science, including analytical chemistry, pharmacy, food chemistry, medical science, this is no stranger, and especially with word chromatography. What are we going to discuss? What is HPLC? Number 2, what is the basis principle of HPLC? Number 3, what is the variant of HPLC? Number 4, what are the instrumentation of HPLC and what is their function? How does the HPLC work? What are the advantages and limitations of HPLC? And the last question, what are the applications of HPLC? Okay. Before I continue to discuss, I want to say don't forget to subscribe and like and comment for this video, okay? Especially in my channel. So don't go anywhere. The separation principle of HPLC is based on the distribution of the analyte or sample between a mobile phase element and the stationary phase or packing material of the column. Depending on the chemical structure of the analyte, the molecule are entitled while passing the stationary phase. The specific intermolecular interaction between the molecule of the sample and the packing material define their times on the column. Hence, different constituents of the sample are eluted at different times. Thereby, the separation of the sample ingredient is achieved. The detection unit or UV detector recognizes the analytes after leaving the column. The signal are converted and recorded by the data management system by computer software and then shown in chromatogram. After passing the detector unit, the mobile phase can be subjected to additional detector units. A fraction collection unit ordered to the waste. In general, HPLC system contains the following modules: solvent reservoir, a pump, injection valve, a column, detector unit, and processing unit system. The solvent or element is delivered by the pump at high pressure and constant speed to the system. To keep the drift and noise of the detector signal as low as possible, a constant and continuous flow from the pump is crucial. The analyte or sample is provided to the element by the injection valve. Okay, this is the principle of HPLC system. Next, how does the HPLC works? Okay. I want to give you a chart of HPLC works. This figure, okay. You look the instrumentation of HPLC and how does the HPLC work? Okay. Number 1, this mobile phase reservoir, pump, injection system or injector, and then column, detector, and data processing unit, data system, and waste reservoir. Okay. The mobile paste will flow towards the column and detector. The column contains the stationary paste. Okay. Mobile paste or solvent or eluent. Yes. The mobile paste is pumped with high pressure. And then flows to the injection system, and then to column and detector. The rest of mobile paste go to waste reservoir. The sample is injected through unit of injector. Yes, can be single injection or automated injection system or autosampler in here. And then the sample will be column. Into the column, there will be separation based on the interaction between sample, mobile paste, and stationary paste. So in the column will be separation based on the interaction between sample, mobile paste, and stationary paste. The separation result will be detected by the unit of detector, and the separation result data can be displayed and with data processing system. Okay. This is the simple flow of HPLC works. Okay. Okay, friend, this is one of the example of data analysis. Okay, this is for HPLC. This is X line is time, retention time, and Y line is absorbance. This is the separation of the sample in the column and can display and collected in data system collector. Yes, this is can be see the benzoic acid, benzonitrile, and 2-amino pyridine. Yes, this is the one of the example of HPLC result for this analysis. Okay. Okay, friends, this is the one of the modern HPLC by Agilent. Okay, HPLC instrumentation include the pump, injector, column, detector, and integrator or acquisition and display unit system. Number one is solvent reservoir. Mobile paste contents are contained in a glass reservoir. The mobile paste or solvent in HPLC is usually a mixture of polar and non-polar liquids. Components with respective concentration are varied depending on the composition of the sample. Number two, pump. A pump aspirates the mobile paste from the solvent reservoir and forces it through the system's column and detector. Depending on the number of factors, including column dimensions, particle size of the stationary paste, the flow rates and composition of the mobile paste, operating pressure of up to 42,000 kilopascals, about 6,000 psi, can be generated. This is for pump. Number three, sample injector. The injector can be a single injection or an automated injection system or autosampler. An injector for an HPLC system should provide injection of the liquid sample within the range of 0.1 to 100 milliliter of volume with high reproducibility and under high pressure, up to 4,000 psi. This is for injector. Column. Columns are usually made of polished stainless steel, or between 50 and 30 millimeter long and have an internal diameter of between 2 and 5 millimeter. They are commonly filled with stationary paste with a particle size of 3 to 10 micrometer. Columns with internal diameter of less than 2 mm are often referred to as microbore columns. Ideally, the temperature of the mobile paste and the column should be kept constant during an analysis. Number 5. Detector. The HPLC detector located at the end of the column detects the analytes as they elute from the chromatography column. Commonly used detectors are UV spectroscopy, fluorescence, mass spectrometric, and electrochemical detectors. Waste reservoir. The rest of the sample and effluent will be automatically discharged and collected in the container. Number 7. Data collection device. Signals from the detector may be collected on a chart, recorders, or electronic integrator that vary in complexity and in their ability to process, store, and reprocess chromatographic data. The computer integrates the response of the detector to each component and places it into a chromatograph that is easy to read and interpret. Additional instrument for HPLC is the Detector. The effluent used for LC analysis may contain gases such as oxygen and are non-visible to our eyes. When gas is present in the effluent, this is detected as a noise and causes an unstable baseline. The Detector uses special polymer membrane tubing to remove gases. The numerous very small pores and the surface of the polymer tube allow the air to go through while preventing any liquid to go through the pore. The additional instrument others is column heater. The LC or liquid chromatography separation is often largely influenced by the column temperature. In order to obtain repeatable results, it is important to keep consistent temperature conditions. Also, for some cell analysis, such as sugar and organic acids, better resolution can be obtained at elevated temperatures 50 to 80 Celsius degree. Thus, columns are generally kept inside the column oven, column heater. Okay, this is the instrumentation or the part of HPLC in general. Okay friends, I want to show you one of the modern HPLC from Agilent. Okay, this is the unit of Agilent HPLC with 1216 into model. Okay, I want to show you this is the mobile paste system, mobile paste reservoir, LM or solvent, and then this is the flow, this is the pump, include the gasket for remove the gas or bubble, and then go to the column, this is column unit, and then this is autosampler or autosampler, and this is detector. After detector, the data can be displayed and analyzed by computer. This is the unit of Agilent. Okay, this is the column. The example of column for HPLC. Yes. This is the column for HPLC. Yes. Include stationary paste. There are 4 variants of HPLC system. Number 1, normal paste HPLC. Number 2, reverse paste HPLC. Number 3, size exclusion HPLC. Number 4, ion exchange HPLC. Okay. Normal paste HPLC. This method separates analytes on the basis of polarity. NP-HPLC uses polar stationary paste and non-polar mobile paste. Therefore, the stationary paste is using silica And typical mobile paste are hexane, methylene chloride, chloroform, diethyl, and a mixture of this. So the key of normal paste is the difference of mobile paste and stationary paste. For normal paste, the stationary paste is polar and the mobile paste is non-polar. Number 2 is reverse paste. The stationary paste is non-polar, okay, different from normal paste. For reverse paste, the non-polar liquid is for stationary paste, while the mobile paste is polar liquid, such as mixture of water and methanol or acetonitrile. It works on the principle of hydrophobic interaction, hence in more non-polar the material is no longer it will be retained. Okay, so I will explain for two variants, and the next time I will explain for the size exclusion HPLC and ion exchange HPLC. Okay friends, for the other application of HPLC include number 1 in pharmaceutical applications, include to control drugs stability, tablet dissolution study of pharmaceutical dosage form, or pharmaceutical quality control in industry. Okay. Number 2, the other application of HPLC is for environmental applications, for detection of phenolic compound in drinking water, biomonitoring of pollutant. The next for application in forensic, quantification of drugs in biological samples, for identification of steroid in blood, urine, etc., and forensic analysis of textile dyes, and determination of cocaine and other drugs of abuse in blood, urine, etc. And then for application food and flavor, measurements of quality of soft drink and water, sugar analysis in fruit juice, analysis of polycyclic compound in vegetable, and preservative analysis. Application in clinical tests, urine analysis, antibiotics in blood. Antibiotics analysis in blood can be analyzed with HPLC system. Analysis of bilirubin, analysis of biliverdin in hepatic disorder, and detection of endogenous neuropeptides in extracellular fluid of brain, etc. Okay, this is other application of HPLC. Industry, pharmaceutical, environmental, forensic, food and flavor, and clinical tests. Okay. I want to tell about advantage and limitation for HPLC. Speed, good speed for analysis. Number 2, the advantage is efficiency. Number 3 is accuracy, good accuracy for analysis. And number 4, versatile and extremely precise when it comes to identifying and quantifying chemical components. But beside advantage, HPLC have limitations. Number 1 is the cost, high cost. The speed is advantage. HPLC can be costly, requiring large quantities or expensive organics. Number 2, complexity. Number 3, HPLC does have low sensitivity for certain compounds, and some cannot be detected as they are irreversibly absorbed. And number 4, volatile substances are better separated by GC chromatography, not with HPLC. Okay, this is for advantage and limitation with or for HPLC system. Okay friends, this is one of the product of Shimadzu HPLC. Yes, this is, we can see the different from Agilent. Okay, I will show you the instrument for this HPLC. This is LWAN or mobile phase reservoir. This is, and then this is degasser to remove gases or bubble, and then this is the pump. There are two pumps, pump A and pump B. This is the mixture of from pump A from pump B. Okay, this is mixer, and then go to the autosampler. Yes, this is the autosampler or injector. This is, there are 70 for 70 vials and plus 10. The total vial can be injected is 80. This is the autosampler. This is the SPDM20A detector, diode array detector, and then this is CBM20A for prominence communication with model. After that, this is the computer for data analysis system. Okay, this is the unit of Shimadzu. This column can be displayed in beside the unit, and this is the waste container. Okay, next to the software. Okay, for the software, this is the software. We use LC solution software for Shimadzu.